Live. Okay, so today I think it's going to be easy for you. 4, 14, 22. Okay, so it says graphics calculus. So let me go ahead and look. Go to my Desmos. Right, if I go y equals the square root of x. Square root of x. X, there we go. There it is. There it is, right? And there's no graph back here because there's no square roots of negative numbers, right? An easy way to do this is we know that we've got the square root of 0, square root of 1, square root of 4, square root of 9. Now I didn't write down any of the other numbers because they're just ugly decimals, right? So I'm just going to graph these numbers instead of, I don't want 2 because it's about 1.41. Square root of 3 is about 1.73. Aren't I a nerd that I know these? Pretty much, right? Okay, I own it. So if I am to graph square roots, I know the square root of 0 is 0. If I go over 1, the square root of 1 is 1. I'm going to go all the way to 4. Because the square root of 4 is 2. I'm going to go all the way to 9, 4, 5, 6, 7, 8, 9, because the square root of 9 is 3. When I connect the dots, all the rest of the values are there, right? Easy? Okay. Yeah, square root of 3 is there, square root of 2, they're all there, but we don't need those. We just need to graph it with a few points, okay? Domain, what's the domain?
X is greater than 0.
Or equal to, very good. Yes. And what's the range?
Y is greater than 0.
Or equal to, yes.
Oh,
yeah. Okay, very good. So then if that's our parent function, let's call that our parent function. Then what we can do is simply take this graph on example 2 and just bring it down 4. So we're going to do a vertical translation, and we're going to take it, we're going to translate down 4. All right, so I'm just going to take this parent function, just bring it down 4. So it's going to start there. It's the exact same graph. Exact same graph. So I'm still going to do the over 1. Square root of 1 is 1. Okay, square root of 1 is 1. I'll go over from my endpoint 1, 2, 3, 4. Square root of 4 is 2. I'm just taking my parent function. I just brought it down. We go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. And of course, everything in between when I connect the dots are there. All I did is I took my parent function and brought it, vertically translated it down 4, okay? Domain, what's the domain? What's my domain? Which one's my domain? What's my domain? What's the domain? Yeah, Gabe?
X is greater than or equal to 0.
Yes, because it does still start at 0 for the x's and moves forward. Good. And what's the range? Gabe?
X is greater than or equal to negative 4.
Perfect. Yes, y is greater than or equal to negative 4. Absolutely. Starts at negative 4 and goes up. Awesome. Okay, example 3. We're going to take our square root graph and we're going to move it to the left 3 and down 2, right? We've done this before, so this should be pretty easy. So y to the left. Why am I going to go to the left?
Because it's opposite of what's in the square root.
Exactly. And now here's a great example of an opportunity for me to show you why. So my endpoint is here, right? Okay, here's a teachable moment. This will tell you why. This will tell you why it has to be the opposite. If x is negative 3, I want you to see this. This is why it is the opposite. Let me show you why it has to be the opposite. What's negative 3 plus 3? 0, right? What value in here will make it 0? The opposite. And if you do that, then it brings it down to its corresponding or starting point. That's why it's always got to be the opposite, because the opposite will zero that out. Oh, hopefully that makes sense. Okay. So then I'm going to do the same exact graph. I'm going to go, okay, from here I'm taking my parent function 1, 1. I'm going to go over 4. 1, 2, 3, 4. Square root of 4 is 2. I'll go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. And there is my graph. Missed that one. Okay. Domain.
X is greater than or less than negative 3.
X is greater than or equal to negative 3. Yes. And what's the range?
Y is greater than or equal to negative 3.
Awesome. Easy? Okay.
Yes.
Turn the page. Would you like something easy for change? Okay. All right. Now, cube roots. So if I take a look on Desmos, I'll get the idea of what it should be. But if I want to do y equals, let's see if it'll do a cube root of x. Well, I can do it this way, okay? I can do an x to the 1/3 power. Let's see if it'll do it. Oh yeah. 1/3 power or cube root, same thing. We know that, right? Everybody agree with that? We know that. So it looks like that, doesn't it? Well, before I put it down, let's list my perfect cubes, right? Cube root of 0, cube root of 1, cube root of 8. I can also do the cube root of negative 1, cube root of negative 8. Okay, I'm just going to write those down. So these are the cube roots that are perfect cube roots. Cube root of 0 is 0, right? Cube root of 1, what times what makes 1 is 1. Cube root of 8 is 2, you agree with that? Cube root of negative 1 is negative 1, because negative 1 times negative 1 is negative 1. Cube root of 8 is negative 2, because negative 2 times negative 2. So these are the numbers I want to graph, and it makes my curve much easier to graph, okay? So let's put these down. So I know that the cube root of 0 is 0. The cube root of 1 is 1. So now I'm going to go all the way over to 8. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And the cube root of 8 is 2. I'm going to go to negative 1. The cube root of negative 1 is negative 1. I'm going to go all the way to negative 8. 1, 2, 3, 4, 5, 6, 7. Negative 8 is here. And the cube root of negative 8 is negative 2. And I'm just going to connect the dots, okay? So this is the parent function of the cube root. We've seen this before, haven't we? There's my parent function. All right? Yeah, what's my domain?
All real numbers.
It is all real numbers because it goes forever both directions. And not only that, but we can put any number. It really represents what are the values of x. It could be anything, can't it? We can put in anything. You can take.
What's the fix your window mean?
Oh, back in the day, we used to use a graphics calculator quite a bit, and now we don't because you guys use Desmos. So
That's setting the dimensions of the graph. right?
yes, yes, for my window. Yes, exactly right. So all real numbers. And what's my range? What?
All real numbers.
It is, even though it's always going up. It is all real numbers. Good. All right. All right. Now, last example. So it doesn't have an endpoint, it doesn't have a vertex, but it has what we call an inflection point. We've talked about that before as well, right? It has an inflection point. I need to move the entire graph. The entire graph is going to move. So for me, it's easier just to move the inflection point and then do my square root of 1, square root of 8, right? So I'm going to move my inflection point. So I'm going to go to the left, 3, and down 5, right? So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, which is right there. And then I'm going to do my same My parent function, same exact process, but I'm going to move my parent function to here. So I'll go over 1. The cube root of 1 is 1. I'm going to go all the way to 8 because that's the next perfect cube. So I'm going to go all the way to 8. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 because the cube root of 8 is 2. Okay. I'll do the same thing with negative 1. I'll go back 1. The cube root of negative 1 is negative 1. I'll go back 8. 1, 2, 3, 4, 5, 6, 7, 8. And the cube root of negative 8 is negative 2. And there's my parent function. All right. Domain. What's the domain? X equals all real numbers. Range. Y equals all real numbers. Okay. What do you think? Not too bad? So what I'm going to do is try and give you, I don't want to give you a lot of homework because I still want to keep working on these balloons. Someday it won't snow and we'll have a sunny, beautiful day and we'll launch, right? In the meantime, we just keep waiting for it to stop snowing, don't we? All right. So we're going to do page 121. And I just want you to, let's just do 1 through 4 all, okay? Page 121, 1 through 4 all, that's it. Super easy assignment. And then when you get done with that, we can work on our balloons, okay? Sound good?